In this video, we're going to focus on naming carboxylic acids. So the basic functional group of a carboxylic acid looks like this. It has a carbonyl group and also a hydroxyl group. So this is your typical carboxylic acid. Sometimes you might see it written this way or even this way. So let's work on some examples. Let's begin. Let's start with this one. So here we have a 6-carbon carboxylic acid. So the first thing you want to do is you want to count the longest chain. So we have a total of 6 carbons. 6 carbons is associated with the name hexane, but instead of calling it hexane, it's going to be called hexanoic acid. Now, what if we have an alkene present? How will that affect the name of this particular compound? So once again, you want to count the longest chain, and you need to assign a carboxylic acid with a 1. You always want to start counting from the carboxylic acid. Now the alkene is between carbons 3 and 4. Now you want to pick the lower of the two numbers, which is 3. So this is going to be called 3, not pentane, but pentene, and then oic acid. Anytime you have a carboxylic acid, you need to add the suffix oic. Now what about this example? Let's say if we have a carboxylic acid that looks like that compared to one that looks like this. What's the name for these two carboxylic acids? In this case, you want to use the ENZ system. For the example on the left, the two groups with the highest priorities are the methyl and the carboxylic acid. Comparing the carboxylic acid versus hydrogen, the carboxylic acid functional group has way more priority than the hydrogen atom, and methyl has more priority than hydrogen on the left side. So whenever your two highest priorities are on opposite sides, you have the E isomer, and whenever they're on the same side, you have the Z isomer. So in this case, this is the Z isomer. But now, what is the name of each of these compounds? So let's count the longest chain. We have 4 carbons, and the alkene is on carbon 2. So this is going to be called E-2-butenoic acid. Now the other one is going to be the same thing, but the only difference, instead of E, it's now Z-2-butenoic acid. Now let's move on to our next example. Try this one. What is the name of this particular compound? So we need to start counting from the carboxylic acid. And which group has higher priority? The ketone or the carboxylic acid? Typically, the groups that are always at the end usually have more priority than the ones in the middle. So the carboxylic acid will be associated with the parent name. So how can we name a ketone as a substituent? This is going to be called 4-oxo, and after that, just the rest of the name, which is hexanoic acid, since we have a 6-carbon chain. So ketones and aldehydes have the name oxo whenever they're the substituent instead of the parent chain. Let's try another example like that. So this time we have a carboxylic acid and an aldehyde. Both groups are always at the end, but the carboxylic acid has more priority than the aldehyde. So the carboxylic acid will be associated with the parent chain of the molecule. NH2, the amine, as a substituent is called amino, and the ether, this is known as ethoxy as a substituent. So we need to start counting it from the carboxylic acid. So this is going to be called 4-amino. We need to put it in alphabetical order. Dash 7-ethoxy. Dash 8-oxo for the aldehyde. And then octanoic acid. Now what about this? What if we have a ring and a carboxylic acid? What is the name of this molecule? So we have 6 carbons in a ring, so it's a cyclohexane ring, plus a carboxylic acid. So this is simply called cyclohexane carboxylic acid. Now, what if there's some substituents attached to it? Let's say if we throw in a bromine atom and a methyl group. How can we name it? So automatically, this is going to be carbon 1. It's associated with the functional group that has the highest priority here. Now, we need to decide, should we count it counterclockwise or clockwise? Now, if we count it counterclockwise, we're going to have a substituent on 4 and 6. If we count it clockwise, the 2 substituents will be at 2 and 4, which is better. So that's the way we want to go. And then we just got to put it in alphabetical order. So B comes before M. This is going to be called 2-bromo dash 4-methyl. And then after that, cyclohexane carboxylic acid. Now, how about this one? What's the name of this particular carboxylic acid? So the carboxylic acid has more priority than the ketone and the alcohol. Now, H comes before O, so this is going to be 4-hydroxy and then dash 5-oxo. Since we have a 6-carbon chain, hexanoic acid. Now, what if we have a benzene ring with a carboxylic acid functional group? What's the name of it? So if you add benzene and oic, you're going to get benzoic acid. Now, what if we add an alcohol and an ether to it? How can we name it now? So in this case, we want to count it clockwise, so we can get the 2 substituents at 3, 4 instead of 4 and 5. And then just put it in alphabetical order. So H comes before M. This is going to be called 4-hydroxy dash 3-methoxy. And then benzoic acid. Notice that whenever you have an oxygen, you have the word oxy. Here you have a hydrogen attached to the oxygen, so it's hydroxy. And here you have a methyl attached to the oxygen, methoxy. I don't know if you caught that, but it's something useful to know. Now, what if we have two carboxylic acid functional groups in the same molecule? What do we do? So you need to use the word dioic since you have two carboxylic acids. But first, identify the longest chain. So it's 4 carbons. This is going to be butane. And instead of saying butanoic acid, it's butane dioic acid. So now that you understand how to name the last example, you can try this one. So we want to start counting from the side that's closest to the methyl and the ethyl groups. So the methyl could be on carbon 2 and the ethyl could be on carbon 3, as opposed to it being on 4 and 5. So the parent name is going to be associated with hexane. And then we have 2 carboxylic acids, so hexane dioic acid. And now we need to talk about the substituents. E comes before M, so this is going to be called 3-ethyl dash 2, I put 4 for some reason, don't know why. So 3-ethyl dash 2 dash methyl, and then hexane dioic acid. So that is it for this video. Thanks for watching and have a great day.